Hello, ladies and gentlemen. Here is the short intro into the last chapter of Chemistry 12, kind of a big deal. We're going to talk about a couple specific types of reactions in this chapter called oxidation reduction reactions. Lots of it you would have seen before, but we are putting a slight twist on it. All we are looking at in this chapter are where are the electrons. It's kind of the game. Find the electrons. There are four massively important definitions to start this chapter off. They're all typed out here for you. We'll be reviewing these in countless different ways in class. Pause the video, jot these four down. Unbelievably important. Okay, now that you've written them down, even though I know you're listening to the video straight through, this is your classic chapter 5 reaction. This reaction says Cu plus 2 is going to react with zinc solid. They're going to exchange electrons, two of them for that matter, to form Cu solid and Zn plus 2. What we care about in this chapter, where are the electrons going? Well, to figure out where the electrons are going, we need to know the charges. Well, the charge of Cu plus 2 is given, plus 2. The charge of Zn solid is a 0, so it's a 0. Cu solids are zeros, and Zn plus 2 is obviously plus 2. So from 0 to plus 2 for zinc, that's a loss of 2 electrons. And copper plus 2 to copper 0, well, that's a gain of 2 electrons. So the electrons are actually going from the zinc to the copper. Transfer of electrons, that is an oxidation reduction reaction. Specifically, we call this a redox reaction. Redox reactions is the combination of oxidation reduction. Right? It's not called oxred. It's called redox. Don't ask me why. Someone probably knows. It's just not me. So we need to figure out where the electrons are going and label the species that's getting reduced and label the species that's getting oxidized. We also have to label the species that's causing oxidation to take place, and we have to label the species that's causing reduction to take place. So here's a fantastic little way to remember two of the four definitions. It's classic. None of this is me. I can't take credit for it, but I will change it around to put my own twist on it, which you'll like in a couple of days. We are going to say Leo the lion says grr. Okay? Leo is lose electrons oxidation, gain electrons is reduction. That's how you're going to remember those definitions. Leo the lion says grr, but expect an Arcuri twist here in a few classes. Some people may want to think about what the charge is doing. This completely messes me up, but if it helps you, great. If you're getting oxidized, your charge is getting more positive. I have no pattern for that whatsoever. But the reduction one makes a lot of sense. If you're getting reduced, you're getting smaller. Think of it that way. Your charge is getting more negative. It's going down. So if your charge is going down, you're getting reduced. So if you can remember that one, then you can remember the oxidation one, which to me has no pattern. Okay? Here's another example. Carbon copy from the first one. Pb plus 2 to Pb0. Mg0 to Mg plus 2. Mg is losing those 2 electrons, giving them to Pb. Mg is losing electrons, that's oxidized. Pb plus 2 is gaining them, it's getting reduced. That's how good you need to be. You need to know those definitions lightning fast. Here's one that I'd like you to try. Okay? We'll make sure you get the answers to these tomorrow in class. But spend 30 seconds and give this one a shot. It's worth it. We can write reactions, instead of full redox, we can write them in half reactions. Half reactions are either losing or gaining. It's not doing both, like the two examples that we've just seen. So you can start off with a full redox reaction like this, but you can still figure out what the half reaction is. So Pb plus 2 is going from plus 2 to 0. From plus 2 to 0, that's gaining 2 electrons. So this is the reduction half reaction. Okay? The reduction half reaction simply shows the species that's gaining the electrons. The oxidation half reaction is the other half. You have no choice. Once you label one, you know the other one. The oxidation half reaction is when it's lost. And when it's lost, the electrons are going to be released, and they're going to be on the right side. So here's an example that's kind of got some tricks in it. Have a quick peek. This is the intro, ladies and gentlemen. You're going to be doing some work on this tomorrow. Really, this chapter starts after the first couple of sections, so it's an easy one today. 5.2 is a little more tricky, and we combine everything together in 5.3. So try to watch that 5.2 video in class tomorrow, dial this in, and get ready for the next class where we start putting things together. See everyone later.